Hi, thank you. So today I'm going to be talking about Fusion for Business Intelligence, and thank you all for joining the webinar. Today's session is going to have the following objectives. We're going to talk at a very high level to gain some awareness on the variety of search and discovery functionality that's available out there. There's a lot of different ways of getting to the information that you need, and we want to make sure that you're able to select the right product for the right particular use case that you might have. And we're going to have some fun along the way too, and hopefully you'll find out why this baby is so happy, because there's a story that goes along with that. With that said, here's our agenda for the day. I'm going to talk about the beer and the diaper legend, and then we'll get into the data, information, knowledge, wisdom pyramid. And then we'll talk a little bit about enterprise search, start to get a little more technical when we get into indexing, although it's not to be a discussion, an in-depth mathematical discussion on indexing, but at least a broad enough brush so that you can get the foundation of what's involved in developing a good search, and some of the things that relate to that, and some of the things that go beyond basic indexing to get the relevant results you need. Finally, we're going to look into statistics and compare that to data mining and machine learning and artificial intelligence, and kind of see how they all relate to each other. Then we'll delve into a little bit of a discussion about business intelligence and what it is and how that fits in with Fusion. And then ultimately, hopefully, be able to, at the end of the day, pick the right tool for the right job to get the relevant results you want. So let's dig in and get started with the story about the beer and the diapers. And there's many versions of this. It's pretty entrenched in BI mythology. It's been around for a long time, actually. And the legend goes like this. That some time ago, a large retail chain decided to combine the data from its loyalty card system with that from its point-of-sale systems. And so the loyalty card system gave the demographic data about its customers, and the point of sale told it where, when, and what those customers bought. And once all of that information was combined, the data was mined extensively, and they found lots of correlations. A lot of stuff that you would expect, like people who bought gin were also likely to buy tonic and also probably bought lemons or limes. However, there's one correlation that stood out like a sore thumb because it was so unexpected. They found that on Friday afternoons, young American males who bought diapers also had a predisposition to buy beer. And so then legend has it that based on that information, they moved the premium beers to the end of the aisle where the diapers were, and sales of both went up. Now, whether or not that's true, there's really no evidence of that fact. But the point is that no one had predicted that kind of result. So no one would have been able to ask the question about beer and diapers in the first place without having mined the data. And the difference then here is between data mining and querying. Ultimately, getting to that level of what you need to know may not be through querying because you may not know what to ask. So there has to be some analysis of the data that goes on as well. And so like all good myths, the beer and diaper story has its origins in fact, but most of the details are probably wrong. But it makes a good story to understand the difference between querying and data mining, and ultimately to gain true knowledge. I just want to give a quote from Mark Twain, who once said, "Get your facts first, and then you can distort them as much as you please." So I think that is probably what happened with this legend. With that, we'll talk a little bit about the whole reason for data mining and querying, and that's ultimately to get the relevant information, right? You have to look at what the end user is trying to achieve. What's the use case, and what does the end user need to know? And this also brings up then the whole data pyramid that you're seeing in front of you. And it's been part of information science again for many years, just like the legend has been. But it makes an interesting point to keep in mind when you're using these discovery kinds of tools. data is the bottom, of course, and it's the biggest part of that whole pyramid, and bigger by the day because of the volume and the velocity and the variety of data that's coming in. Now we're dealing with structured and unstructured data. We're dealing with vast amounts of things coming at us very fast. So it's all unorganized and unprocessed. So it has no real meaning other than it's just data. So once you've got that data, then you have to do something with it to organize it. Even the unstructured data you have to find some structure in that as well. And then you can develop some relevance. So now you've got the data that's been processed, and it rises to the level of information, which in and of itself is good, and that's where we were for many years with our different search mechanisms that we had. The information that's inferred from the data is what we want then to bring us up to answering the kinds of things like who, what, when, where, how many, and then with that information we're able to make some useful use of that information to make decisions or take some kind of action. Then more recently we've reached the level of taking that information and bringing it to knowledge. And so knowledge can be described as a synthesis of multiple sources of information over time. So that's where a lot of the analytics that we have today is coming from. Organization and processing to convey an understanding of some type of experience and accumulated learning. So we refine the information to a point where we have some kind of knowledge, some insight, you might say, to gain and help the person make a decision. Ultimately then at the top of the pyramid we have wisdom, and that's where some value is added to that knowledge that allows some kind of judgment. Some kind of judgment is being made on all of that knowledge. And by doing that, you're able to gain even further insight. So today, a lot of the cognitive systems that you might see out there try to achieve wisdom. Whether or not you actually get to the top of that pyramid ever is a question for debate. Wisdom is probably the most subjective of all of the items in this pyramid, but at some point we do reach a point where this wisdom is helping us to make those decisions as well. So that brings us to the concept of enterprise search. Where does enterprise search fit into that whole quest for knowledge and wisdom, really? And in enterprise search, you've got a situation where you've got a mountain of data and it's located in various different silos. Unfortunately, the question that's posed here about what do you do with all of that data, the answer is it depends on what you need it for, right? Given the differences between searching and discovery, you really have to look at the intent of what you're trying to achieve, your use case, and the scale of all that data that you're trying to work with. So you can ask questions like, do I need a commercial search tool? To what extent does the data need to be analyzed? A simple search just enough, or do I need some analysis on that data? How much data and what kind are we searching or discovering? Are we working with structured data or mostly unstructured data? And the big question for a use case is, what are we hoping to find out from that data? We may not know what we're going to find out until we start doing some analysis, but having a sense of where you want it to go is important when you're building a use case. The thing to remember about enterprise search is it's not just searching the web. It's not just looking for different documents. It's a little bit of all of that. It's federated search these days. The most popular phrase currently is intelligent search, which kind of is a blend of business intelligence and enterprise search. We have also things like data warehouses that do data mining. So where does that fit into intelligent search? And data warehouses, content management systems, enterprise search tools, and business intelligence tools are all different flavors that do different things specifically, but also sort of blend together. And ultimately, all of those tools, the goal is for the end user to be able to get what they need. And the ultimate question is, what exactly is it that you need? What are you trying to achieve? So these are some of the aspects when we isolate just enterprise search from all of those possible tools. We have things like crawling, parsing, indexing, searching. That's the basic functionality of any enterprise search system. Then you have to ask, do I need to do advanced kinds of searches? Do I need facets on my search? And facets are things that allow you to do some discovery, such as, narrowing, filtering down your result set, or prioritizing in different ways. Am I going to be searching structured data? Am I going to be searching unstructured data? Is there metadata? Oftentimes, if you're trying to search binary files or movies or sound or pictures, you really want to leverage that metadata so that you can do searching based on that as well. Do I want there to be some kind of collaboration with the end user where they can do ranking and what are the results? How do I want the results to look? Then there's a whole other aspect of enterprise search that revolves around security and what kind of control access can I control the access to that search tool. What do I want the UI to look like? Is it going to blend in and be integrated into my existing UI, or is it going to be, am I just going to use the UI out of the box and modify that and then add that as a separate page to the user experience? How do I tune all of that indexing that's been done? What kind of reporting do I need? How much analysis do I need in that reporting? You're starting to get into, in that area, some of the business intelligence aspects. And then ultimately, what kind of performance am I expecting and what kind of scale? All of those are things that you need to consider when you're looking at an enterprise search tool. And so here's an example of Fusion, and Fusion as an enterprise search engine, how that fits in. Fusion is a platform that sits on top of Solr and Spark. It's powered by those two open source search and analysis tools. Over on the left-hand side of this diagram, you can see all the different data sources that we're trying to combine into Fusion. So we've got things on the web, on the cloud. We've got big data in Hadoop systems and databases. So we're dealing with structured and unstructured data of all kinds. It's being fed into Fusion, where we're leveraging Fusion's connectors, and we're then able to use Solr to do some of the indexing. It's going through pipelines and security, and all that stuff is being taken care of at Fusion's level. Then over on the right-hand side, the output is also being handled by Fusion, where we can do simply searching, we can do some discovery, as I was talking about with facets and things like that, gaining some insight into the data. So here's where we're starting to get into some of that business intelligence and some analytics that are involved, and ultimately make some recommendations to our end users, do some editorialization, do alerts, personalization. All those things are sort of what comes out of the query pipeline. So I'm going to talk a little bit now about pipelines themselves. We've got two sets of pipelines, an index pipeline and a query pipeline. So first, we're going to, with Fusion, we're going to connect to the different data sources. Over on the left there, you see documents, but it doesn't necessarily have to be documents. It can be web pages or whatever database result sets, whatever you're trying to connect to. And Fusion has a number of connectors for those different kinds of sources. Once it's been connected, the data sources go through first an indexing pipeline. And you see represented there the different stages in that pipeline. And here's just a list of a few of some of those stages that are available while Fusion is doing its thing, including things like open source TIKW parsers. It's doing some field mapping. It's transforming HTML. One of the more interesting things that's going on too is we can do open natural language processing. OpenNLP does entity extraction on the data, so that's really great for things like unstructured data where we need to identify things like people or places. that starts to get into more of the sophisticated kinds of machine learning that we have, where we provide models to Fusion in our configuration so that it can process that information and identify those entities that we're trying to achieve and isolate for further analysis. Ultimately then, the indexes are being held in Fusion, and we are then able to do queries against those indexes. On the query pipeline side of things, again, there's a number of stages once you submit the query so that Fusion can understand what it needs to look for, how it needs to look for it, and what it needs to give back to the end user through the search UI. And again, you see below the query pipeline over on the right a list of the different kinds of stages that we can use, including things like developing facets, developing boosts for relevant results. Ultimately, we're trying to get relevant results out, and the query pipeline is a great way to provide that relevancy. And also, at the same time, we can do things like security trimming and things like that, making sure that the end user has appropriate access to the information that's coming back in the results. So now we're going to delve a little deeper into what's going on the indexing side of things. This discussion could seem a little technical. It's a little overwhelming. I'm trying to keep it as high level as possible because this could take a whole computer science class to discuss. And that's really not the point of this discussion. But it's also good to understand kind of the way things are going on, the way things are working. In the typical, in the early days of indexing, we were just looking for keywords. So during the process, you would collect the data and parse it and index it so that you can get that fast retrieval. Indexes, when you think of it like the alpha sorted index in the back of a book, you can get the exact content where you're trying to find in the book just by looking in the index, finding the page, and then going to that page. It's much faster than reading the whole book and looking for that one thing. At the reality of it, in any search functionality, that's what's going on too, but in a lot more complex way. Without this kind of indexing, we just wouldn't have very good performance at all. So then you have to sort the index. And here we're talking about, there's a thing called barrels. And so the occurrences of a keyword or something are translated into hit lists and written into barrels. And then the barrels are inverted. So you can see here in the diagram an example of that. And it looks very complicated. But the computer handles that very quickly and is able to find exactly what you're looking for. And then also, because we need to get some kind of relevant result sets back, we want to look at scoring the results. And the term frequency and inverse document frequency is a mathematical algorithm that you see there that allows for developing some very fundamental way of looking at how the information is relevant to the query that's been done. So how many times did that keyword show up, that sort of thing. It's basically, that algorithm gives you a numerical score, and it's assigned to each result that comes back in the search set in from the query, and it represents how well the results meet the information. That needs some kind of tuning sometimes, and so there's things that go on that allow you to modify that algorithm to make it even more relevant. There's clustering. So the cluster hypothesis in information retrieval says that two documents that are similar to each other have a high likelihood of being relevant to the same information. So by topic clustering and document filtering algorithms, you can get that relevant information come to the top of your result sets based on the score that they get. And one last really technical slide, and then we'll move into something hopefully a little bit more high level and meaningful. But this is really the heart of it. in terms of relevance, right? We want to get something really useful back. And here's a Venn diagram over on the left. You see all of the documents. Well, obviously, everything you search is not going to be relevant to your query, right? So we know right away that it's going to fall into probably one of two categories. There's either going to be all of the relevant documents or a relevant response set that's coming back from your index query, right? And in a perfect world, those two circles would completely overlap each other, but in reality they don't. So it goes to a question of recall versus precision. So the instances are basically a set of relevant documents, and you're given a search term. Each document gets one of two categories. Either it's relevant or it's not relevant. So in this case, the relevant documents are just those that belong to the relevant category. Recall is the number of relevant documents retrieved by a search divided by the total number of existing relevant documents. And precision is defined as the number of relevant documents retrieved by a search divided by the total number of documents retrieved by that search. So they're kind of opposites. The sweet spot, obviously, is the middle, the retrieved relevant documents. And that's what we want to be able to deliver and get something back. So you want to try to find that sweet spot where you've got all the relevant documents and the ones that actually are responsive to your query. So a lot of terms are thrown around about those aspects of search. And one of them relates to statistics, one of them relates to data mining, and then machine learning, which has sort of a ancillary artificial intelligence. And I'm going to actually address each one of these from artificial intelligence up the list. So artificial intelligence is distinct from all the rest of these because it's the study of how to create intelligent agents. In practice, it's how to program a computer to behave and perform like an intelligent agent, like a person. And this doesn't have to involve learning or induction at all. It can just be a way to build a better mousetrap. So that's the artificial in artificial intelligence. It may appear to be intelligent, but it's just processing stuff. Things are becoming more like actually learning by virtue of the fact that we're starting to develop some natural language processing tools that allow us to develop and have the computer develop a better understanding of what's being asked, so therefore it can behave and reason appropriately. But most tasks that require that kind of intelligence require the ability to induce new knowledge from experiences. So that's where machine learning comes in. You have models, a large area, and it's really kind of an area within artificial intelligence. A computer program is said to learn some task from experience if its performance at that task improves with the experience. Machine learning involves the study of algorithms that can extract information automatically. So you don't need a human in there guiding it along. It's certainly the case that some of these procedures include ideas derived directly from or inspired by classical statistics, but they don't have to be. And we'll get to statistics in a moment. See how they're all kind of interrelated here. So now how does that compare to data mining? Data mining is carried out by a person in a specific situation on a particular data set with a goal in mind. Usually the goal is either to discover or generate some preliminary insights in an area where there's little knowledge beforehand. So think back to the beer and the diapers. That's really an example of looking for patterns through data mining. And with that, you're able to predict some future observations, hopefully more accurately. Data mining procedures could either be unsupervised, we don't know the answer, like the beer and the diapers, or supervised. We know the answer before we ask the question, and we just want confirmation. We will be able to do some kind of predicting. Finally, statistics is concerned with probabilistic models, specifically inference of these models using data. So it's pure number crunching, and it has an important role. Don't undervalue the role of statistics in all of the other aspects of search and relevancy that we've been talking about here. But there's a common common phrase in statistic analysis. It says correlation does not imply causation. So you have to be careful when you're crunching numbers, because it doesn't necessarily mean the same thing as you would get from some of the other tools that we have available. That brings us into a discussion of what is business intelligence. So there's a number of BI technologies, and they all sort of provide information about historical, current, or predictive views of business operations. That's the simplest definition of business intelligence. It's made up of a number of components, including the multidimensional array, aggregation and allocation, also known as OLAP, online analytical processing. It involves denormalization, tagging, and standardization, usually related to relational databases. There's some real-time reporting with an analytical kind of alerting system. There can be a method of interfacing with the unstructured data sources, again, data mining, some group consolidation, aggregation, that sort of thing, statistical inference and probabilistic simulation, so we're back to statistics. So, and also key performance indicators, looking for that, version control and process management, and open item management. And so that's all of the things that a BI tool can give you. Whether or not you need all of those for your use case is something you have to examine. So then let's talk about how Fusion handles analytics and some of the BI that we just talked about. So Fusion allows for the secure access to dashboards and does some work with the logs during its indexing pipeline. Spark is running the analysis models for the logs and leveraging it in the index pipeline. And then there's some time series index management that's going on as well. So you've got speed. Solr can query, sort, facet, and generate basic statistics across a very large set of results very quickly. So that performance is crucial in doing some of that analysis. It's got incredible scale. Over the past year at Lucidworks, we've seen numerous Solr cloud installations come online with hundreds of nodes and hundreds of billions of documents, and Solr continues to be adopted for that massive scale. Solr 5.1 contains 48 new features, 50 bug fixes, and 60 optimizations from over 70 contributors. So we're really getting to leverage what's going on with Solr when we're doing this analysis of the logs. And it's just a more cost-effective way to do that, some of that analysis. And so as we talk about massive scale with log analytics, first and foremost, the architecture that you see there is designed to support organizations that need to search and analyze billions of logs and events in those logs every day. And because it's time-oriented, the nature of the logs, users need to analyze them based on specific date ranges, either the last few minutes, today, past few days, all kinds of date ranges. And of course, most organizations are expanding their need and their log analytics solution to scale with the business while keeping costs under control. So it's a very useful tool that Lucidworks has to offer here. The thing in Fusion that we use to do the log analytics are two things called signals and recommendations. So Fusion can capture store and aggregate signals from a variety of sources. And signals can include things, they're basically events. So they can include things like clicks and queries. Maybe you're adding to a cart if you're in retail, or some kind of purchase behavior. Things like geolocation, user behavior preferences, anything that is going on the user side of things that are events that can be captured. Fusion does that, and then it aggregates it into a log file that can be indexed and used to drive predictive search capabilities and all kinds of relevancy tuning. So there's some machine learning that's going on here as well. And finally, as we get into more of the analytics, there's another product that Lucidworks has called Silk. And Silk has dashboards that provide a really rich visual interface for users so that they can really visualize some of that BI and the event and log data. Silk stands for Solr Integrated Logstash Kibana. And so Logstash is an open source tool for collecting, parsing, and storing logs for future use. And Kibana 3 is a web interface that can be used to search and view the logs that Logstash is indexed. So what Silk does is it provides a rich visual interface for users so that they can search, inspect, and visualize event and log data, create personalized and shared dashboards and reports across your organization, gaining quick insight into network health, application availability, and data security. So Silk can be used as an enterprise-grade solution for storing, analyzing, and managing billions of log messages from users across a variety of servers. And whether your data is sitting in log files on disk, coming across the network, or stored in Hadoop clusters, Silk provides a variety of ways to ingest your data. In addition to time series data, Silk supports the visualization and inspection of non-time-based data, including documents, emails, database tables, and more. What I want to say, though, is I want to set some expectations that Silk is, while it does analytics, it's not a tool, a BI tool like Tableau or one of the other BI-specific tools. But what can be done is you can use the broader search, enterprise search functionality that's available within Fusion, and then connect Fusion with some of those other BI tools out there, and then either leverage their visualization or use the visualization that comes here and communicate between all three of those tools to come up with a really powerful solution. Again, it depends on your use case. So this is where Fusion fits in. And basically, it's interacting with the users through a REST API. And we have a Lucidworks View that gives us the UI, and we have an admin UI that allows administrators to configure Fusion to do what it needs to do to provide the useful results and the relevant results back to the end users. Part of Fusion's core services involve natural language processing, scheduling, alert messaging, connectors, all those indexing and query pipelines I talked about earlier. And that whole platform, again, is connecting to all those different kinds of tools that you have out there, including some of your data warehouses, including some of your BI tools, including web-based cloud solutions, databases, big data, all of that stuff. Those connectors are very crucial to being able to do what you need to do quickly in a good, in a secure way. It's all sitting, all of that, those Fusion services are sitting on top of 3 open source tools called Apache Spark, Apache Solr, and Apache Zookeeper. So there's things going back and forth between all of that architecture that allow for scalability and security, and ultimately Fusion provides a lot of value on top of those open source services. With that, I just want to put a plug in for finding out more about Fusion and more about relevancy in search, and maybe even seeing some demos. We're offering a Lucene Solr conference called Revolution. It's coming up next month in October in Boston, and you can learn more at that URL that you see below there. Also, I'm told that this Friday the reduced pricing is going to be over and the prices will be going up. So if you have any inclination to join us at Revolution, I hope you do. Be glad to talk to you more about this stuff there. And there's also some great seminars that you can find out more about at that link. Please join us, and if you get the opportunity to sign up before Friday, you'll be taking advantage of a lower price. So with that, I want to thank you for those of you who made it through that whole discussion and open it up for some questions and answers.
Great. Thank you, Allan. So as Allan mentioned, we will now begin the Q&A portion of the session. If you have any questions, you can still enter them into that chat box on the bottom left side. So we do have a couple questions. We may have covered some of this, but we can go over it again for maybe those who joined late. So the first question is, how would your tool help me visualize my data?
Okay. So the tool offers dashboards. And so the data that you're coming back with results can go through those dashboards, and there are different panels within the dashboard. And you can configure those very easily through the admin tool to provide you with different kinds of result sets. So the result sets, if it's quantifiable, can be put into some kind of charting if that's useful. It can be put into geolocations if that's useful. Whatever panel you want can have certain result sets for you, but it all comes out on the dashboard through the UI.
Great, thank you.
Sure.
Next question. How customizable is the pre-processing mechanism at index time?
It's very customizable. So we have, through the admin tool, a graphic user interface that allows you to input all the different various stages that we have. You can choose whichever ones that are relevant to the data source that you have that you want to be processing. And when you do that, each one of those stages has all of the important fields that you need to fill out to have that stage run properly. And so it's very easy to configure.
Great, thank you. Can Fusion be a replacement for data warehouses or repository databases?
That's a good question. I wouldn't recommend. It becomes one of those things of choosing the right tool for the right job. And while you might be able to use it for some of the things that you'd find in a master data management system, I would not recommend using it as a master data management system. It's still an enterprise search tool. But what can be done, which I think is really relevant, is you can use the enterprise search functionality of Fusion to clean up the data that's in your data warehouses so that then you can interact with it more efficiently. And by doing those kinds of searches, most data warehouses have some kind of search capability, but it's not as powerful as an enterprise search engine would be. So you can leverage the enterprise search functionality to clean up your data and then use that data warehouse as a data source with much cleaner data then.
Great. The next question is, in terms of subjective metadata, i.e. user clicks, cart entries, etc.,
yes.
How quickly is that information made available to query and visualization engines, i.e. how quickly is it indexed?
Good question. That's something that you can control through the scheduler. The admin tool has the opportunity to create a schedule. And what has to happen is each one of those events is logged in a log, but those logs then have to be aggregated. So how frequently you aggregate that information and roll it up into an index is something that you can control through the scheduler, and it can bring it almost up to near real time if you want.
Great. This question may have the same answer, but I'll ask it anyway. Can we do real-time analytics based on the data that has been indexed, like cost reports, project timelines, expenses, etc.?
Sure. I mean, I think that did kind of get answered a little bit in the sense that through the scheduler you can determine how frequently you want that index to be updated. We do incremental updates on our indexes, And so it doesn't take as long to index the increments. And depending on the data source, you may want something to change more rapidly than another data source, for instance. Some data sources don't change more than once a month, but others change by the minute. So you can select which data sources you want to be incrementally updated more frequently. And then by doing that, take that information and pass it through different queries on a more frequent basis and get to something close to real time.
Great, thank you. The next question is, are there any indexers made for predictive analytics, i.e. feature engineering and analysis?
I think that could you repeat the question?
Are there any indexers made for predictive analytics, i.e. feature engineering and analysis?
So indexers themselves, the indexer is coming through Solr, and there are features that are available in Solr that do allow for some type of prediction, but it's more on the query side where you're actually taking what's been put into the index and you're trying to do some analysis on that side. The analysis that's done during indexing time is more agnostic, I'd say.
Thank you.
You can do, on the indexing side, you can do things like some semantic analysis, things like that, if you're trying to get into some of the more sentiments and things like that, and how one keyword relates to another keyword in context, things like that.
Great. How could I use Fusion as a view on my Hadoop content?
Well, you could use Fusion as a view on your Hadoop content in the sense that you would connect to your Hadoop file system and then index the results that come back that you want from your how you configure your connector. And once that's indexed, then the result sets that come back from any queries are being queried against the index and not the actual Hadoop file system itself. So you're getting those results passed through the UI from the indexing.
Great. How do you configure Fusion, Silk, or Signals to work with a shopping cart?
Well, that's kind of a complicated question. I think we should probably take that one offline, but it can be configured to do that.
Okay.
And it's mostly done through the UI and the different APIs that we have available.
Great. What kind of NLP and ML libraries are supported in Fusion?
All of the open source ones that are out there, there's a number of libraries that are available open source that can be downloaded and incorporated into Fusion. When you're configuring the OpenNLP stage and indexing, you just plug the appropriate models in the appropriate places in the configuration UI. And then you can also develop your own models as well and use those.
Thank you. So this is going to be our last question. It is, how about near real-time data feeds? Would we be able to process streams of data?
Yes, Fusion does process things like RSS feeds and social media, Twitter, and things like that.
Great. Thank you, Allan. So it looks like we got through the bulk of the questions. If you think of anything once we close the session, you can email events@lucidworks.com, and we'll make sure to have someone connect with you and get that question answered. Otherwise, thank you very much for joining us today. Everyone who registered for this webinar will receive a link to the recording and the slides within the next few days. And we hope you have a great rest of your day. Thank you.